Hello and welcome to this lesson on measures of central tendency and dispersion. So you're going to see here central tendency is talking about, that's your mean, median, and mode. Numbers that tend to be in the middle of the data. And dispersion talks about how spread out the data is, or where it's chunked, that kind of stuff. So how do you compare measures of central tendency and dispersion? Did you know mode works best when the data, or when on data that is like categories? So things like your favorite football team, like that's not a number. So you're looking for like which thing happens the most. That's what the mode does. Which happens the most. What meals were bought at lunch? The zip code the phone number has, stuff like that. Like those are categories, not necessarily a list of numbers. Mode doesn't work out so well a lot of times with lists of numbers, unless you're just curious on which one happens the most. So, vocabulary. These are the measures of central tendency: mean, median, mode. The mean is the average. That's what most people think when they think of the average. That's the mean. It's the sum of the numbers, so you add up all the numbers, and then divide by the number of numbers. That's your average. The median is the number in the middle, and make sure you put those numbers in order. So it's the number that would be halfway from the smallest to the biggest when you find the middle number. And the mode is the number that happens the most. Measures of dispersion. In this lesson, we're talking about range. And that's the difference of the greatest value and the least values. That's just, I always think is big minus small. The biggest number minus the smallest number. Over the course of the next few lessons, we're going to talk about other measures of dispersion. Things like stem and leaf plots and box and whisker plots and stuff like that. Okay, so in this lesson, that's how we're measuring the dispersion. The spread outiness of the numbers, which is kind of a weird way of saying that. But like if we have a whole bunch of numbers, and this is another way you could do it, it's called a histogram. So based off this, I can see that there's a lot of data in this section of the graph, but not so much here. That's what dispersion is talking about. It's talking about where are there a lot of data, where is there least data, where are there big chunks and small chunks. Is if I change this data a little bit, I can see that there's more data on this right hand side where like it kind of keeps getting bigger and bigger and bigger and bigger as we move to the right. That's dispersion. That's just looking at where the chunking of the data is, where there's big chunks and little chunks. Okay. And this is just a cute little rhyme that kind of helps you memorize the different mean, median, mode. So hey diddle diddle, the median's in the middle. You add and divide for the mean. The mode is the one that happens the most, and the range is the difference between. So it was something interesting I found online. So compare measures of central tendency. It's right here. The height of 8 waterfalls in the state of Washington are boom, 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 boom. Which measure of central tendency is the greatest? The mean, the median, or the mode? So we have two ways of doing this. Way number one, the old-fashioned way. You take your calculator and you, for our mean, median, mode. So first, let me do mode since I'm here. The mode is the one that just happens the most often. Is there a number that happens the most? There you go. This 1,000 feet is the only one that happened more than once. You are allowed to have more than one mode. I can have modes of 1,000 and 2,000 or 1,268 if there's another one there. Now, median and mean. Since these numbers are already in order, the median is the next easiest one to do. So you're trying to find out which number is exactly in the middle of this set of data. So smallest, biggest, smallest, biggest. I'm kind of like, I don't want to cross them off, but I'm working my way to the middle. Ooh, right here these two numbers are in the middle. The median is then, if there's two numbers in the middle, the median is what is the number exactly halfway between them. And we do that by finding the average of those two. Oopsie. So we add them up, divide by 2. So the median is 1,195.5. Okay, median is the middle number. If there was only one number in the middle, here there were two. If there's only one, then we would just say that one number was the median. If there's two numbers in the middle, you add them together and divide by 2. We'll become very familiar with that when we start talking about box and whisker plots in a little bit. Now, as far as the mean goes, the mean, we're going to have to take all of these numbers and add them together and then divide by, I believe, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yes. So we're going to take all of those and divide by 8. So this is just calculator work. 1,000 plus 1,000 plus, and I'm just going. Oopsie, I put 86 instead of 68. There we go. Do 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 do. All right, add them all up, divide by 8, and we got a mean of 1,344. So that's the old school way of doing this, which is perfectly fine. Now, if you're more of the technology inclined, you can actually do a lot of this using the calculator. You can find the mean and the median of a set of numbers using calculator. So what you're going to do, if you would like to do that, is we click on second list. Nope, wrong one. I always mess that up. Stat, and the first choice says edit. So right now I have some things in here. I think I can delete. There we go. Can't use the clear button, you got to use the delete button. So now if I would type these numbers in here. 1181. I know this is redundant because I just did this, but I want to show you how you can do this using the calculator. And this can also help potentially reduce mistakes. I mean, I don't know, same number of mistakes maybe as you're typing numbers in on the calculator, but it might also be a way of checking your math. So I've typed in all the numbers. Okay, so all my data values are here. Now we are going to click on second stat, go over, and you see all those different things. We could like sort them and fill and all that kind of stuff. But right here, we could find the minimum, the maximum, the mean, the median, the sum. Well, we want to find the mean. Oops, guess I can't be in here. I thought it would take me out. The mean of that first list. So I need to come back in and hit second list and get my L1. So that's going to find the mean of list 1. Hey, look at that. That's the same number I got. And if I find the median, second list, go over to math, median. And the reason why I'm choosing L1 is in here, if I'd go back and edit, this is my list 1. That's my L1. You could have multiple lists going at the same time. So you have list 1 and list 2 and list 3. Okay, but we want to find the median. Number 4, median of second list, list 1, and look at that. Okay, so you can use the calculator. You can do by hand. I don't know if the calculator is any quicker than doing it by hand. Potentially if these numbers were not in order. If these numbers were all mixed up and the first thing you had to do was put them in order, then maybe this is the quicker way. So now here are that same list of numbers. So if you eliminate the greatest and lowest number, which measure of central tendency is the greatest? The mean, median, mode. By the way, we never answered it here. Which measure of central tendency is the greatest? Well, that's the biggest number by a lot. So now if we got rid of the biggest and smallest number, one here and one here, now which measure of central tendency? Well, mean, median, mode. Well, now the mode, there is no mode. There's no number that happens more than once. Now, I could recalculate this, but I could also go in here and edit my list and just delete this one. He's gone. Go down and delete my big one. He's gone. And now I can recalculate my mean and median with my new list. So, mean of L1, 1194.66 repeated. Now, instead of using the calculator like that, I could have added these all together and then divided by 6. Median. If I do, the median actually should be the same number. It should not have changed. L1, and look at that, 1195.5. And it is the same. Because, I mean, it's still right here. That's still in the middle. Biggest, smallest, and you kind of work your way to the middle. There are still these two numbers in the middle, so you'd add them up, divide by 2 to find what is exactly halfway between them. So now, which measure of central tendency is the greatest? Well, actually now, it's the median is the biggest, just by a teensy little bit. So why would eliminating the highest and lowest values affect the mean? So look here. Let me. Here, maybe I'll throw highlighter over them. So if we cross this dude out, we cross this dude out. Okay. So how would eliminating that biggest and smallest value affect the mean? Why would that matter? What do you think? Well, it's because this dude here, he's kind of an outlier. Look at the rest of these numbers. They're between 1,000 and 1,300. Okay, so they're about, these numbers here have a range of about 325 or so. But now this guy, he's another over 1,200 numbers higher than your highest number. He is tremendously higher than the rest of them. So this one outlier here brings the mean of all of these values up. So by eliminating him, we didn't even have to eliminate the smallest one, but by eliminating this one, it makes our mean and our median much closer together. And I don't know exactly what you'd write for that, but maybe it eliminated an outlier. And the mean is very susceptible to outliers. If you have an outlier in your data, it can greatly affect the mean, where one outlier doesn't really have much effect on the median. So as far as choosing the best measure of central tendency, because that's something that, I'll be honest, I've been confused on for years. And it took me a while to understand which one is best. So here's what Khan Academy says. This is straight from the Khan Academy website. It says, mean and median both try to measure the central tendency of a data set. The goal of each is to get an idea of a typical value in the data set. The mean is commonly used, but sometimes the median is preferred. So what that tells me is, if you have a choice, if all the data is fine, choose the mean. Now it goes on and says, the mean is not best. Now this is my own description now. This is not from Khan Academy. The mean is not best when the data has some extreme scores or outliers. And we saw that in the previous problem. When I included the huge number, look at where my mean is. If I would place him in this same number line, that mean is right here. Is that a good average? Does that like represent the rest of the numbers fairly well? Well, no, he's bigger than almost all of them because of this one outlier. So usually the mean's pretty good unless there's an outlier. Here, we got rid of our outlier. If I said which of these was the best measure of central tendency to use, since there's no outliers, the mean is probably the one you'd want to say. This can really throw off the mean. Those outliers can really throw off the mean. Also, it may be impossible to calculate the mean. There are some problems where they don't give you the exact numbers. You can't calculate it, in which case the median should be used. So, the summary. Pretty much, if nothing is wrong with the data, and wrong is in air quotes, if there's no outliers, there's nothing weird about the data, if you can, use the mean. That's the one that people would prefer you use if you can. Now, if the data has outliers or extreme values, or you can't calculate the mean, use the median. So the median's like the backup if there's something wrong with the mean. Mode, you shouldn't really ever use the mode for a set of numbers. The mode only works best with categories, like your favorite type of pizza, where you want to know the one that's picked the most. It's not really used for just a set of numbers. Okay, so that's after some researching, that's the best descriptions I came up with for how to decide which measure of central tendency is the best. Pick the mean if you can. If there's anything wrong with the mean, if it's not near the center, if there's outliers, then use the median. All right. So the lengths of the 9 longest rivers in the US are listed below. Which measure of central tendency best represents the data? So here we have it. So I would like you to try this problem. You can choose to put this in your calculator and do the list. If you wanted to do that, you would have to go into Stat and Edit. And here's your list 1, and you just retype over these same numbers. 1, 2, 9, 0, enter, and it'll just go through and change them. You can do that, or you can do it by hand. It's up to you. So I would like you to decide which measure of central tendency, mean, median, or mode, best represents this data. Go ahead and do that right now. Okay. I'm gonna go ahead and put this data in because why not? This is not something I'm actually really that familiar with. I haven't really done a whole lot of this using the calculator to calculate these values, but I kind of like it. And it's actually fairly easy for me to see if I've made a typo, because I can look back at the numbers. 1420, 1450, 60, and I can kind of go back and forth to make sure everything looks good. Okay. And then check this. Because I've changed it, I can actually just hit the enter button and it'll redo the last thing. The last thing I put in here was median. It just recalculated the median of the new list I just put in there. I didn't have to go through and find junk. So median is 1460. That would be him. He's the median. Good for him. The mean, now a lot of times you can hit up. Oh man. Oh, I might just have to do it. Second list. Go over to math. Go to mean. I want the mean of second list, L1. So the mean of the first list is 1743.3. And the mode is none. There is no mode. All right. Oops, too big. So which measure of central tendency is the best? Well, we can see the median is right here. The mean would be right there. They're both fairly much in the center, right? Does there appear to be any outliers, any extreme values? Not really. Like, they're all kind of, I mean, they're all just increasing a little bit over time. It's getting bigger and bigger and bigger. They're not like a huge jump. So in this case, the mean is probably the one that people would want to use. Given the choice of an average, people think of the mean as the average, unless there was something wrong with it. So mean would be the one to use here. Okay. Same thing, I think there's actually one more after this. Which measure of central tendency would best represent this data? You do not have to find the actual values. I was looking, my T's cut off. So you don't actually have to find the values, just which measure of central tendency would best represent this data. Go ahead and pause the video and try it right now. All right, so I'm looking at this. I'm looking to see, are there any outliers? Is there any huge jumps in the numbers? 35, 42, they're just increasing kind of little bits at a time. I don't see anything tremendously wrong there. I think the mean would do the best. There's no outliers. There's nothing wrong with the data. Letter E, same thing. Find which measure of central tendency would do the best here, and you don't actually have to find it. So you did a survey of your favorite class in 8th grade, and a survey has these results. Okay, so which measure of central tendency would work best there? Well, since those aren't numbers, you can't find the mean, you can't find the median, but you can find the mode. And the mode appears to be, look at that, math. Surprise, surprise, right? So that's a situation where the mode would come in handy, the one that happens the most. So you could say the class that people like the most is math class, based off that data. All right. So given the choice, what measure of central tendency would most people typically use? Go ahead and pause the video. And the answer is the mean. The mean is what people think of as an average. That's the number they think of like in the middle. So if you were given a choice, choose the mean. If that doesn't work, then you go to the median, and you almost never use the mode unless you're talking about something like categories. Okay? Thank you so much for watching this lesson. Until next time, toodles.